This video provides brief information about the artillery used by the United States Army in combat during World War I. The 3-inch gun, model of 1902, commonly known as the 3-inch M1902 field gun, was a light field artillery piece developed and adopted by the United States Army at the beginning of the 20th century. It represented a major step forward in American artillery design and was intended to modernize U.S. field artillery after the lessons learned from the Spanish-American War. Officially adopted in 1902, the M1902 became the first modern quick-firing field gun designed and produced entirely in the United States. The gun had a caliber of 3 inches, or 76.2 millimeters, and was constructed using nickel steel, a significant innovation at the time that provided greater strength, durability, and resistance to wear compared to earlier steel alloys. The barrel was rifled and measured approximately 28 calibers in length, or about 2.1 meters, allowing for improved projectile stability and accuracy. The gun fired fixed ammunition, meaning the projectile and propellant charge were loaded together, which greatly increased the rate of fire compared to older separate loading artillery systems. One of the most important technological features of the M1902 was its hydro-spring recoil system. This mechanism absorbed the recoil energy when the gun was fired and automatically returned the barrel to its firing position, eliminating the need to reposition the gun after each shot. As a result, the M1902 was classified as a quick-firing field gun, capable of maintaining sustained and accurate fire. Under ideal conditions, the gun could achieve a theoretical rate of fire of up to 15 rounds per minute, although in practical combat situations, the sustained rate was usually 4 to 6 rounds per minute. In terms of firepower, the 3-inch M1902 typically fired a 15-pound or 6.8 kilogram high explosive or shrapnel shell. The projectile had a muzzle velocity of approximately 1,700 feet per second, or about 518 meters per second, giving the gun good ballistic performance for its class. The effective firing range was approximately 6,000 to 6,500 yards, or 5.5 to 6 kilometers, while the maximum range could reach up to 8,500 yards, around 7.8 kilometers, under favorable conditions. These characteristics made the M1902 effective against infantry formations, artillery positions, and lightly fortified targets. The gun was mounted on a 2-wheel box trail carriage, which allowed for limited traverse and elevation adjustments. The complete weapons system, including the carriage, weighed approximately 2,520 pounds, or around 1,140 kilograms, making it relatively mobile for a field artillery piece of its era. It was designed to be towed by horses, typically a team of 6, and could be deployed relatively quickly on the battlefield. From a service history perspective, the M1902 field gun entered U.S. Army service in the early 1900s and gradually replaced older artillery models such as the 3.2-inch M1897 gun. Although it represented a significant improvement in American artillery design, its operational use in major conflicts was limited. During the Mexican punitive expedition of 1916 to 1917, some units were equipped with the M1902, but it saw little combat action. When the United States entered World War I in 1917, American forces in Europe primarily used the French 75mm Model 1897 field gun, which was already standardized among Allied armies and available in large numbers. As a result, most M1902 guns remained in the United States and were used mainly for training and coastal defense roles during the war. After World War I, advances in artillery design quickly rendered the M1902 obsolete, and it was gradually withdrawn from active service during the 1920s. Many surviving examples were preserved and can today be found in military museums and historical collections. In conclusion, the M1902 field gun was a crucial transitional weapon in U.S. military history. It introduced modern features such as quick firing capability, recoil control, and improved metallurgy to American field artillery. Although it did not see widespread combat use, its design laid the foundation for later U.S. artillery systems and marked a new era in American field gun development. The 3-inch Stokes Mortar is a lightweight, portable mortar system that was first developed and widely used during World War I. It was designed by Captain Percy Stokes of the British Army in 1915, and it quickly became one of the most important and influential infantry support weapons of the war. The Stokes Mortar was revolutionary in its simplicity, ease of use, and effectiveness, and it laid the foundation for modern mortar systems still used today. The primary purpose of the Stokes Mortar was to provide indirect fire support for infantry units, allowing them to engage enemy positions that were hidden behind obstacles or beyond the line of sight. The mortar could fire explosive projectiles at a high angle, enabling troops to hit trenches, machine gun nests, barbed wire, and other fortified targets. Because of its unique design, it gave infantry units a powerful means of delivering rapid, close, and effective fire without relying on larger and less mobile artillery units. Structurally, the Stokes Mortar consisted of 3 main parts: a smooth-bore metal tube, a base plate, and a bipod support with sights. The tube was the barrel into which the mortar bombs were dropped. The base plate, placed on the ground, helped absorb recoil and stabilize the weapon. The bipod held the barrel at the correct firing angle and allowed the crew to adjust elevation and direction. Unlike many artillery pieces of the time, the Stokes Mortar was designed with simplicity in mind. It could be quickly assembled or disassembled, transported by infantrymen, and operated with minimal training. Its firing mechanism was straightforward. A mortar bomb was dropped down the tube. As it struck the fixed firing pin at the bottom of the tube, the bomb's primer was activated and it exploded, propelling the shell out of the barrel and into its trajectory toward the target. This simple drop-fire mechanism made the mortar fast and reliable under combat conditions. The 3-inch Stokes Mortar earned its name from its bore diameter of 3 inches, which is equivalent to approximately 76.2 millimeters. This caliber struck an optimal balance between explosive power and mobility. The complete mortar system, including the tube, bipod, and base plate, weighed roughly 35 to 40 kilograms, about 77 to 88 pounds, which was light enough for infantry crews to carry and deploy in difficult terrain. The mortar could achieve a maximum range of roughly 800 to 900 yards, that's approximately 730 to 820 meters, depending on the type of ammunition and elevation angle. In the hands of a trained crew, the Stokes Mortar could achieve a rate of fire between 10 and 25 rounds per minute, making it capable of delivering a rapid and sustained barrage on enemy positions. One of the greatest strengths of the Stokes Mortar was its portability and speed of deployment. Unlike traditional artillery, which required teams of horses and lengthy setup, the Stokes Mortar could be brought forward with infantry units and quickly deployed to respond to changing battlefield conditions. This made it extremely valuable during trench warfare, where static positions and short-range engagements were common. The mortar allowed small infantry units to provide their own suppressive fire without waiting for larger artillery support. Because of its success, the Stokes Mortar was widely adopted by British and Commonwealth forces, and many other nations also developed similar systems inspired by its design principles. It underwent various improvements and was produced in large numbers throughout the war. Although later mortar designs would incorporate more advanced features, the basic simplicity, reliability, and effectiveness of the Stokes Mortar ensured its enduring legacy. In summary, the 3-inch Stokes Mortar was a groundbreaking weapon of World War I that transformed infantry firepower. Its simple and robust design, combined with its mobility and high rate of fire, provided frontline troops with an efficient indirect fire capability. It is remembered today as a pioneering artillery system that helped shape the development of modern mortars and had a profound impact on how infantry support was conducted during the early 20th century.
The 4.7-inch M1906 was a coastal defense and seacoast artillery piece used by the United States Army in the early 20th century. It was designed as part of the modernization program of U.S. coastal defenses following the recommendations of the Endicott Board, which sought to replace obsolete smoothbore and muzzle-loading cannons with more modern, rifled, breech-loading artillery capable of engaging enemy warships at greater distances. The 4.7-inch M1906 featured a caliber of 4.724 inches, approximately 120 millimeters, and was intended primarily for use in fortifications along the coast. It was a breech-loading gun with a single-motion interrupted screw breech, which allowed relatively rapid loading and firing compared to earlier models. The barrel was constructed of a steel tube with a jacket and reinforcing hoops to withstand the pressures of firing, and it had a rifled interior to impart spin to the projectile, increasing accuracy and range. The gun fired fixed ammunition, which combined the projectile and powder charge into a single round, simplifying loading and speeding up the rate of fire. Typical projectiles weighed approximately 45 pounds, and the gun could achieve a maximum range of around 12,000 yards, depending on elevation and ammunition type. The 4.7-inch M1906 was mounted on pedestal or disappearing carriages, depending on the specific fortification, allowing for either a fixed or retractable firing position that could be protected from enemy observation and counter-battery fire. The disappearing carriage design allowed the gun to recoil down behind a parapet after firing, then be raised back into firing position using a counterweight or hydraulic system, combining protection with effective coastal firepower. In service, the 4.7-inch M1906 complemented larger caliber coastal guns such as 8-inch and 12-inch rifles by providing faster firing, medium-range defense against smaller vessels and torpedo boats that might approach fortified harbors. While not widely used outside of the United States, the 4.7-inch M1906 represented a transitional artillery design, bridging the gap between older coastal cannons and more modern seacoast defense artillery of the World War I era. By the time of World War I, advances in naval technology and changes in coastal defense strategy gradually rendered smaller caliber guns like the 4.7-inch less prominent, though many remained in service at secondary positions well into the 1920s. Overall, the 4.7-inch M1906 was notable for its combination of moderate caliber, rapid rate of fire, and versatility in coastal defense roles, reflecting the United States' efforts to modernize and strengthen its coastal fortifications during the early 20th century.
The 8-inch howitzer M1917 was a heavy artillery piece used by the United States Army during World War I. It was based on the French Schneider design, the Obusier the 220mm Schneider, and was adapted by the U.S. as the M1917. Its primary role was to destroy enemy fortified positions, concrete bunkers, artillery batteries, and deep trench systems at long range with high-angle fire. The M1917 had a caliber of 203.2 millimeters, 8 inches, and was a classic heavy howitzer designed for firing large shells at steep trajectories. The barrel length was approximately 2.6 meters, giving it a length-to-caliber ratio of L/12. The overall weight of the gun in firing position was around 8,200 to 8,300 kilograms. Its construction was made of strong steel to withstand the stress of firing large explosive shells. The howitzer fired high explosive shells weighing about 90 to 91 kilograms. These shells were highly effective against enemy fortifications, concrete structures, and underground facilities. The muzzle velocity was approximately 300 meters per second, giving the gun a maximum range of about 11 to 12 kilometers, which was very effective for World War I combat conditions. The rate of fire was relatively slow, approximately 1 to 2 rounds per minute, due to the weight of the shells, separate loading of powder charges, and the complex loading procedure. Operating the howitzer required a crew of 10 to 12 soldiers who handled tasks such as loading shells, setting powder charges, aiming, and firing.
The gun's elevation ranged from 0 degrees to plus 65 degrees, allowing for high-angle fire, while its horizontal traverse was limited, often requiring the entire carriage to be repositioned to cover a wider sector. The carriage was a two-wheeled type and was usually transported by mechanical vehicles or artillery tractors. Setting up the gun took time, but once emplaced, it was stable and capable of accurate fire. During World War I, the 8-inch howitzer M1917 was widely used by U.S. expeditionary forces on the Western Front. It played a crucial role in preparing the battlefield for infantry attacks by neutralizing enemy positions from long range. After the war, it remained in U.S. Army stockpiles and was used in limited numbers during the early years of World War II, before being replaced by more modern artillery systems. In conclusion, the 8-inch howitzer M1917 was one of the most powerful and reliable heavy howitzers of its time, notable for its high explosive firepower, long range, and robust construction. It significantly influenced artillery tactics and demonstrated the importance of heavy artillery on the battlefield during World War I.
The 12-inch mortar, also known as the 305mm heavy mortar, was one of the most powerful artillery pieces used in the late 19th and early 20th centuries, especially during World War I. These mortars were primarily designed to destroy fortified positions, concrete bunkers, underground shelters, and deep trench systems. Their main advantage was their very large caliber and the ability to fire shells at a high angle, allowing the projectile to strike directly onto walls or roofs. Structurally, 12-inch mortars typically had a short but very thick-walled barrel, capable of withstanding the tremendous forces of firing large explosive shells at relatively low velocities but steep trajectories. Unlike standard field guns, they were not intended for long-range, flat trajectory fire, but for delivering shells over fortifications and obstacles, making them highly effective against entrenched defenses. During World War I, 12-inch mortars were employed by major powers such as Britain, the United States, and Germany. In the British Army, for example, they were part of siege artillery units, playing a critical role in prolonged bombardments of enemy positions. Due to their enormous size and weight, these mortars were often mounted on railway platforms or reinforced concrete foundations to provide stability during firing. Technically, a 12-inch mortar could weigh several tons. The barrel length was relatively short to allow for high elevation angles, typically ranging from 45 to 70 degrees. The shells themselves were extremely heavy, usually between 350 and 450 kilograms, and contained a large amount of explosive material. A single shell could create a massive crater and destroy reinforced concrete structures. The effective firing range of these mortars was relatively limited compared to modern artillery, usually between 6 and 10 kilometers. Firing rate was slow due to the weight of the shells and the complex handling required. Experienced crews could typically fire one shell every 2 to 4 minutes. Special equipment such as cranes or hoists was often needed to lift and load the shells into the barrel. Operating a 12-inch mortar required a large crew, often between 15 and 25 soldiers. The team included a gun commander, aiming specialists, loaders, mechanics, and personnel to handle ammunition. Preparing the mortar for combat was time-consuming, as it required assembling the barrel, setting up the platform, and positioning the foundation. Overall, the 12-inch mortar was one of the most fearsome and effective artillery weapons of World War I, symbolizing the era of positional warfare. Its primary role was not rapid combat, but rather the gradual destruction of enemy fortifications, psychological pressure on defenders, and clearing the way for infantry assaults. Over time, technological advances gradually replaced these massive mortars with modern rocket and artillery systems, but the 12-inch mortar remains a significant milestone in military history. The 75mm M1897 US was an American service version of the famous French Canon de 75 Model 1897, one of the most influential field artillery weapons in military history. Originally designed in France in the late 19th century, the gun was adopted by the United States Army during the First World War due to its exceptional performance, reliability, and advanced engineering. When the United States entered the war in 1917, it lacked sufficient modern field artillery, so large numbers of French 75mm guns were supplied to American forces, while U.S. industry also began producing the weapon under license. The defining technological innovation of the 75mm M1897 was its hydro-pneumatic recoil system, which allowed the barrel to recoil independently while the carriage remained stationary. This breakthrough meant the gun did not need to be re-aimed after each shot, dramatically increasing its rate of fire and accuracy. Combined with a quick-firing fixed ammunition system and a rapid-opening breech mechanism, the M1897 could deliver sustained and precise fire at a speed unmatched by most contemporary artillery. This made it particularly effective for supporting infantry, suppressing enemy positions, and engaging targets in fast-moving battlefield conditions. In U.S. service, the 75mm M1897 became the standard light field gun during the later stages of World War I. American artillery units used it extensively on the Western Front in 1918, where it proved highly effective against enemy infantry, machine gun nests, and light fortifications. Although originally designed for indirect fire, the gun was also capable of direct fire, which increased its tactical flexibility. After the war, many of these guns remained in U.S. inventories and were mounted on improved carriages, such as the M2 carriage, which allowed motorized towing and greater mobility. From a technical standpoint, the 75mm M1897 had a caliber of 75mm and fired fixed quick-firing ammunition. The barrel length was approximately 2.7 meters, giving the gun a high muzzle velocity of around 610 meters per second. This velocity contributed to its flat trajectory and excellent accuracy. The maximum effective firing range was about 12.7 kilometers, while the practical rate of fire was around 6 rounds per minute under sustained conditions, with short bursts reaching up to 15 or even 20 rounds per minute. The gun could be elevated to approximately 45 degrees and had a limited horizontal traverse, depending on the carriage variant. The total weight of the gun in firing position was roughly 1,500 kilograms, making it relatively light and easy to deploy compared to heavier artillery systems. During the early years of the Second World War, the 75mm M1897 was already considered outdated as a field gun, but it was still used by the United States and other countries in secondary roles. Some guns were adapted for anti-tank use, as the high muzzle velocity allowed them to penetrate the armor of early war tanks at short ranges. Others were employed in coastal defense, training, or reserve units. Eventually, the M1897 was replaced by more modern artillery designs with longer ranges, improved mobility, and greater firepower. In conclusion, the 75mm M1897 US stands as one of the most important artillery pieces of the early 20th century. Its advanced recoil system, high rate of fire, and battlefield reliability revolutionized field artillery tactics and influenced artillery design for decades. In American service, it played a crucial role in World War I and continued to serve in various capacities well into World War II, leaving a lasting legacy in the history of military technology.